experienced an earthquake?
Yes, sir. In Rangeley, Colorado.
Rangeley, Colorado.
Yeah. Crazy.
In Japan.
Oh,
dude.
that's where it gets real right there.
Yes.
Yeah? I'm from Moab. There's actually an active fault line in Moab. Produces an earthquake every 5 to 10 years. Believe it or not. Paul brings up an interesting point. Japan's very active with earthquakes, so is Alaska. And we're going to talk about Alaska a little bit today. But this is the Pacific Ring of Fire. You've probably heard of it, right?
Yeah.
Most of the volcanic and earthquake activity in the world happens right here. Okay. So obviously Japan gets a brunt of it, and so does the Aleutian chain, the Aleutian Islands and southern Alaska. Then there's Chile. This is a very active zone over here. Rumor has it, California is way overdue for a big one. So if that's what the scientists think. They don't really know a lot about earthquakes, to be honest with you. But if you have a lot of stress buildup, right, the more buildup there is, when the tension's released, the bigger the earthquake's going to be, right?
Oh, so that's going to be so big.
There was an earthquake, the second biggest ever recorded, in Anchorage in 1964 in Alaska. Okay, 600 miles of fault line ruptured at once. Yeah, right? It released a bunch of stress all at once. So 3 minutes of shaking at a 9.2 magnitude earthquake. Okay, now let's give you an idea of that.
High buildings.
You have no idea.
Yeah.
It's 1964, man. They don't just have videos.
Just do a video of like a really
so those of you that have been in an earthquake, I've been in Alaska. There was a magnitude 5, and it shook pretty good.
Did you cry?
Every magnitude higher is 10 times as powerful. So at magnitude 9 is 10. 6, 7, 8, 9, 10 to the 4th times more powerful. 10,000 times more powerful.
Gee whiz. Is that
okay?
Energy?
So that was centered right where that star is. Here's southern Alaska. So to give you an idea of how big of an area this is, when I lived in Anchorage, we drove to Chicken, Alaska. It's actually called Chicken. It's right near the Canadian border. Okay. That's a 12-hour drive. Yeah, it's a long ways. Okay. And Alaska goes like to out here. So this earthquake was right in the middle of most of the population of Alaska. About 75% of the state lives right in this area. Okay. 9.2 was created a tsunami in Seward that was 40 feet tall. 40. Can you imagine a 40-foot tall wall of water running at you?
Yes.
Okay. Seward was completely wiped off the map. The town of Valdez, where that red dot is, was goodbye. Okay. So lots of destruction. In today's dollars, there's $2.3 billion worth of damage.
Oh yeah. Mr. Ryan's showing us like houses that sunk into the ground.
Yeah. So check this out.
It was awesome. I'm terrible.
It was awesome. Okay, so okay, here's Valdez, and it's in winter, by the way, so it's not like you can just go out in the sunshine afterwards. This is March. It can still be really cold in Alaska in March, obviously by the snow cover. Okay, here's some of the more telling photos.
Dang.
Most of Anchorage is built on a little peninsula, but it's just like beach sand. Beach sand liquefies in earthquakes, especially ones like this. Okay, so just to kind of pique your interest there. Okay, there's Whittier. Believe it or not, built on rock. not built on rock, right? Where'd the boat go?
Man, that's right by my house.
Yeah, no kidding, right? Valdez, right? There's some more, might be Seward. Okay, so this thing's picking up trains and just tossing them everywhere, like nobody's business. Let me see here. There were some really good ones. Hey, how about that? Your house is now in the middle of the ocean. Okay, bridges. Okay, here's some of the more telling photos of what happened in Anchorage. There was the maximum amount of uplift in some places was like 40 feet of change in elevation. Anchorage averaged about 10 feet of change. There are pictures of stores, and the street literally is as high as the roof. Like the store sunk, the street rose, and now there's like, there you go, right? So it was pretty nasty. I talked to people that lived there at the time. Yeah, tell me about it, right? One of the ladies I taught with was in this earthquake when she was a child. Can you imagine doing that to a railroad track? She said they went out of their houses, everybody did obviously, and it was shaking so hard that they would see their neighbor, and then they wouldn't see their neighbor. They'd see their neighbor, and then they wouldn't see their neighbor. It's crazy, right? Okay, so here's the question of the day. How do they know where that earthquake was centered? You draw the epicenter, right?
Yep.
How do they know where it was epicenter?
God told him.
God told him, he just said, boom, it was right here.
Yep.
45 miles west of Valdez and 75 miles east of Anchorage.
Yep. That's how it happened.
Yeah, that's not how it happens.
Science.
Sorry. Okay.
Science.
Any ideas? Okay, strength. Maybe the strength could have something to do with it. That's a good guess.
Or unless it's like a hurricane or like the eye of a hurricane where there's like nothing there.
Earthquakes definitely shake the most violently at their epicenter.
That's what I thought.
Yeah. Good. You're thinking. Any other ideas?
Vibrations. Define how far the signal has dissipated.
You're on the right track.
That's right.
Okay. Do they know exactly what time it hit these cities?
Yeah, probably.
Yeah, they do, obviously, because it started shaking real violently. A lot of clocks probably stopped. There's very little battery-operated clocks back then. So you cut the electricity, you have an exact timestamp of when the earthquake hit these cities, right? You can, knowing what type of wave the earthquake generated and how fast it travels, you can generate a distance from each of these cities and figure out where that earthquake was centered. Okay, and we do it. They have to do it with spheres because it's a three-dimensional model. Okay, because this is a subsurface earthquake. It was 15 miles deep. But if you want to know the point on the land where this earthquake struck, we can use circles to figure that out. Kelly.
You know the seismic graph that goes like this?
Yep.
Where does that get its like input?
Vibrations in the ground.
That's it?
The
So
harder
just
the
sitting
ground
on a table,
vibrates,
it
the
shakes.
more this thing does this.
So
It's a pretty simple
if you
mechanism.
just did this, it would shake.
And it would draw a line on a paper. Yeah, it's pretty straightforward. Now there's some science in tuning it so it measures correctly, but okay, so we have to use circles to figure out where that was. Right? So that's what we're going to look at today. Yeah, they're pretty neat, right? So, we have the unit circle. So we could start off with the unit circle. What's the radius of the unit circle? 1, right?
Yeah.
not pi. Thank you for that.
Can't blame the man.
He thought I didn't hear him because I'm deaf. So r is 1 of the unit circle, right?
Yeah.
Where is that circle centered?
0, right there.
Yeah, center. Okay. You all right, Brandon?
I'm fine.
So I have a location and a size, right?
Yeah.
That's all I need. I can write an equation for that circle and locate it on a grid. Okay, so there's my x coordinate of the center, right? 0. And I can do my y coordinate of 0. Are those going to matter in the end? No, we can get rid of them, right? And my radius is 1, right? So that equals 1 squared. Okay, that's your general equation for a circle. You got your center location and your radius. So this one is x squared plus y squared equals 1. Right? Good with that? Okay, it's pretty straightforward. Now, can I move my circle around?
Yeah.
And I can change the radius?
Yeah.
Right, so let's graph a circle with that equation. That's an x. What's the center of that circle?
No,
Nope.
just 3 negative.
3, -2. Okay, yeah, good catch there. Notice in the original, we're hanging out in opposite land there. Okay, so when we do this, it's the opposite of what's there. Okay, what's the radius? 4. Square root is 16, right? So that's r squared. Okay, keep that in mind. Okay, now you can graph it. Don't worry about your circles being perfect. There's probably never ever been a perfect circle drawn. It's just perfect enough that we can't see the issues with it. All right, there's our center, right? And 4, 4, 4. Okay, so I just draw the radius in 4 spots and then I just connect the dots. It's all right. Good enough, right?
That is perfect. Yeah. Beautiful.
Perfect's a pretty bold word to use in this case.
Perfect.
No. Good enough. That's what I'd say. Good enough, right?
Perfect.
Okay, it's pretty straightforward. You good with us? Okay, Kellen.
Can you go back?
That one. Good? Okay. All right, so again in math, what we do is we generalize things. So if you look in your book, you'll see that the center of a circle, X and Y, they're labeled H and K. So we're using every letter of the alphabet that we can. Okay, so the center, that's the X and that's the Y. The radius is labeled R, We're pretty inventive mathematicians. What we want to come up with is a general form of the equation. So x minus h, y minus k, and r squared. Okay. So there's your generalization. Okay. Good? Or am I going too fast? Okay. Sometimes when I get really excited, I'm like JoJo, the Idiot Circus Club. I get going too fast. That's probably from a movie you guys have never seen. What?
Are you that excited?
Over
Once in a
earthquakes
while.
and devastation.
Yeah, isn't it cool that 120 people died in an earthquake? No, it's not. Do you know 16 of the people that died in that earthquake died in Oregon and California?
What?
Fun fact, what'd they die from?
Not a fun.
Cancer?
Tsunami.
Oh.
An 11-foot tsunami hit Hawaii.
Gee whiz.
How far apart are those? Right from
More than North
Alaska to Hawaii.
This-
Yeah, a bunch of people lived on the coast. 15-foot tall wall of water hit the coast of Oregon and California and killed them.
16.
16 people. Yep. Okay. And let's just talk about a couple situations I might run against. If I give you 2 points, let's say we have the center and some point on the circle. Can you calculate the radius
Yeah.
using what? Right, the distance formula. Okay, so we would calculate the radius using the distance formula possibly, right? Okay, so that's one thing you might see. What if I gave you 2 points on the circle and asked you to find the center?
Midpoint.
Yep, midpoint, right? So keep in mind, you're going to start using distance and midpoint quite a bit. And this is what we call analytic geometry. We're using geometry to analyze, so analytic. Okay. Good enough on that? Kellen?
Real quick, with the distance formula, I believe, in the homework, like in the back of the book, it would give this weird, like, square root thing. But if you looked it up, it's just like the average of this. Can you explain the square root deal? Where that one?
If I knew what square root thingies and deals were, I could probably help you out there. If you could give me a problem number, and I will look at the answer, and I could probably give you what the answer would be. Okay. So are you talking about something like an answer like this?
No, like, to find the midpoint or distance.
Oh.
Or whatever it was. Or, yeah, it might have been midpoint. They put a big square root inside the square root.
The distance formula. Big square root.
Yeah.
So it's,
Yeah. Yeah, but I use just the average. And that's what you do.
okay, the distance formula has a square root, right?
Yeah.
The midpoint is the average of the x's and the average of the y's. So is that what you're thinking?
Yeah.
Okay, yeah, so this is add the x's, divide by 2. That's an average. Add the y's, divide by 2, average. So, yeah, okay. Those are the formulas that I've always seen for distance and midpoint. Okay. All right, back to our earthquake problem. Where was the epicenter of the 9.2 earthquake?
Right.
Okay. through deductive reasoning, we figured out that the earthquake was 78 miles east of Anchorage. Valdez, not Valdez, Valdez. I don't know why they say it this way. It was 45 miles west of Valdez. Okay, and Whittier, it was 40 miles northeast, I think. Okay. So given that information, can we write circle equations and figure out where the epicenter was?
Yeah, we can,
Yeah,
probably.
we can, right? We can use Anchorage as our basis, right? Make it easy, correct? Valdez, if you go east and south, is, let me think, I figured this out earlier. Got 152. Let me go to my map and make sure that's right. My writing sucks, apparently. Okay. So we're creating a grid basically to put the circles on, right? So Anchorage is going to be 0, 0. Okay, where's Valdez? These are 20-mile intervals. So 1, 2, 3, 4, 5, 6 and a little bit. We're being really scientific here. 6 and a little bit, right? So what, 126-ish, 130? If these are 20-mile increments, right?
125.
Okay, let's use 125. And how far down? -5? Okay, so we're going to have 120, -5, right? And what about Whittier? It's right here. So this is Whittier, Valdez, Anchorage. The earthquake is northeast of Whittier, right? All our locations are based on the epicenter. So if we're east of Anchorage, west of Valdez, northeast, we're going to be somewhere in here probably. We just need to pinpoint it. So Whittier, 1, 2, 1.8. How many miles is that? Probably 40, maybe 45 miles east, and how far down? What did you say? This is 40 miles, right? 20, 40, so what, 35 maybe?
38.
What did I say? 45, -35, right? Okay, what are your equations for your circles? What's the Anchorage circle? X. Right? What's 78 squared? Bummer. 6,200-ish? I don't know. Anybody?
78 squared. What? That's like 6,084.
Yeah.
Okay, 6034?
84. 80.
Ah, so close. What's the equation for Valdez's circle? X minus 120 squared. Y plus 5 squared. He said minus negative. We're good. And what's 45 squared? 2025? Okay. And then Whittier. 40 squared, 1600. Okay. So if I plot all those circles, we're going to be approximate here. Because this is not going to be perfect, but it gives you an idea of what goes on, right? And to be honest with you, if I'm doing this, I probably wouldn't even put these numbers on there. Do you need them? No, what you're going to be using is the radius anyways. Okay. So I wouldn't even worry about squaring those. You don't need to, you don't have to. Okay. All right. So Anchorage. How far? Let's see, we're 78 miles east, right? So 20, 40, 60. Here's what, 78 somewhere in there? And that circle, 20, 40, 60, if 80 was here, right? So you've got a big old circle that looks like that. That is all the 78-mile markers from Anchorage, right? On this circle is anywhere 78 miles from Anchorage. So the earthquake at this point could be anywhere in here, correct? Okay. What about Valdez? Let's go. 40, how many? 20, 40, 60. I wonder if the distances I pulled were wrong. I said 78, right? I did. 45 miles west. I don't think those circles are going to intersect if we do it right. Look at this. 20, 45 miles. Do those circles intersect?
No.
So we have some bad information.
Conspiracy.
This is conspiracy. There was one website that said 55 miles. Should we use that? Yeah. Okay, we'll just use that. This is what happens when you pull things off the internet, right? Okay, let's go back here. So 20, 40, 55 would be somewhere in here, right? Where would 55 be here? Ish? Yeah, I'm ignoring it.
Inside story.
Hello. Okay. Bye-bye. Okay. Woo, come on. Spawn. Don't throw the electronic pen, it tends to break them.
No.
Oh, goody. Did we lock up? Okay, so without my pen working,
You could use Expo.
these circles intersect in two spots, right?
Yep.
So we have two possible locations of the earthquake now. There, and what would be up there. Oh, you guys suck. Threw off my groove, man. Okay. Like that, right? We could be there or there. We need one more circle to determine which one of those is the right spot. Okay, obviously it's going to be Whittier. How far were we away from Whittier?
40.
40 miles? Does that look to be about 40 miles? Yeah, sure, give or take, right? So Whittier's circle is going to come through here, something like that. All right, and you can see where they all three intersect. That's where your earthquake was epicentered. Okay?
Is that accurate?
This map is not quite accurate. The method is accurate, extremely accurate, actually. Obviously, like I said, they do it in 3 dimensions, but you can get an idea of how it happens here with circles, 2-dimensional circles. Okay. So that's a graphical system of equations. Remember solving systems of equations with graphing? That's just what we did. Yep. And we got a location. Could we algebraically solve that and get an exact answer?
I think you
Yeah.
if you believe.
You bet we could.
Are we going to?
Do you want to?
Yeah. Yeah.
Come on. Come on. Come on. You know you want to.
Is the pen turned on? That's the wheel now.
They're on. I just charged them. Okay, well, we're stuck. I'm not going to require that you know systems yet, but it's the last section in this chapter. Okay, but you could algebraically solve this system using your equations and get an exact location in x and y coordinates. Okay? Any questions? Okay, but for now, all you need to be able to do is graph a circle, write an equation, find centers and radii. Okay? It's pretty straightforward. There is some really nasty algebra in this section if we want. Do you want to? No, I don't think so. Conics can get really nasty. We try to keep it simple, stupid. Okay? So, I guess so.
That'd be good.
What are we doing? Come on.
Okay, not a whole lot of work there. 6, 7, 8, 9, 10, 11 problems, if I can count. Sometimes I can't. It shouldn't take you very long at all. In fact, you have 10 minutes, you could probably get at least half of it done.
I see.